recording. So a couple of procedural things before we get into class for real. First off, homework is next due. Oh, my internet connection is unstable. That's not good. Okay, we'll see what happens. Homework is next due on Friday at noon. So I set up a spot for you to submit your homework on Moodle. Hopefully that should work out okay. Did everybody do their homework of finding a program to convert pictures to PDFs? If not, do that before Friday at noon. And remember that I have a differential equations class at 11:30. So if you run into issues with submitting your homework, you can't ask me at 11:28. I will be available before 11:30, but not otherwise. All right, that was the first thing. The second thing is that you should have gotten an email because Moodle pushes it out automatically. I uploaded to the announcements forum the link for all the Zoom meetings. So it's right there on Moodle. You don't have to keep going back through your email or wherever it is. It's on the front page of Moodle. That's the second thing. Third thing is a new flexible grading scheme, personal grading scheme has been uploaded to Moodle. And I was thinking about this. I'll put it up as a Word document also because right now it's a PDF and I don't know if everybody has a printer or a way to edit PDFs. So that is up on Moodle and I asked for that to be submitted by next Monday. Okay, so take a look at that new personal grading scheme. It should be up on Moodle under what? Under class handouts, I think, or class resources. Class resources, it's under class resources, so you can get it there. That I think is all my procedural stuff. Any questions at this point that anybody has? I can see you all right now, so you can either raise your hands virtually or for real. Anything right now? Okay, here's the next thing. When I share my screen for PowerPoint slides, we'll do that. We'll pop up PowerPoint. I can't see all of you anymore. So there are good things about having a big class, but there are also bad things about having a big class. So I can only see about half of you at this point in time. So if you have a question, you're gonna have to virtually raise your hand and it will pop me up. I can see some of you, but not all. Okay. So here we go, cryptography. So we were in the middle of signature schemes, yes? And you were supposed to remember what was, or what were the two types of processes in a signature scheme. So we were verifying, signing a message first of all, and then we were verifying two types of processes in the signature scheme. We talked about the RSA signature scheme like 2.5 weeks ago, which feels like forever ago, because that's basically RSA in reverse. So today we're going to do is introduce a new cryptosystem for sure, and then we'll see if we have time to get into a new signature scheme as well. All right, so before we can do this new cryptosystem, we need to talk about the integers mod n. So here's a quick recall. We did this at the beginning of the semester when we were doing all the number theory stuff. Oh, and by the way, these PowerPoints are on Moodle now, so you can decide how you want to do this. So we did this at the beginning of the semester. Remember, for an integer mod n, zn star. So zn by itself is all positive integers less than n. That's without a star. That's just zn. And then if you do zn star, it's all of the integers less than n that are also relatively prime to n. Okay, so those are the two different groups that we're working with. We are going to consider zn star in this case. That's the one we want to be dealing with. All right, and remember also that the number of elements in Zn star is phi of n. Number of elements in Zn star is phi of n. Remember, that's the Euler phi function, and we talked about how to evaluate that as well. So this is review. You don't have to write these down, but here's a couple of examples for small values of n. So Z4 is 1 and 3. 2 does not work in there because 2 and 4 are not relatively prime. Z5 star is 1, 2, 3, and 4. Everything is relatively prime to 5. Z6 star is just 1 and 5 because 2, 3, 4 are not relatively prime to 6. So it's just 1 and 5. Z7 star is 1 through 6. Z10 star, we need to take out 2, 4, 5, 6, 8. And then we have Z20 star and ZP star in general. Okay. So, ZN star. Everybody good? I can see most of you now. I don't need to see my PowerPoints because they're in front of me. So everybody's good so far? ZN star? Okay, all right. Okay, the integers mod n, we also want to talk about, and if you've taken abstract algebra with me, we want to talk about angle brackets around an element. So angle brackets around the element A means that you take A and raise it to powers, and then you stop when you finally get 1. So you take A, you raise it to powers, and you stop when you finally get 1. The name of this, if you've taken abstract algebra with me, is the cyclic group generated by A. Cody, that should be reminding you of things. Mandy, Elijah, Sarah, I don't know who else has taken abstract with me. Joshua, no. So the cyclic group generated by A, that's what that one's called. So you basically just raise powers until you get 1 back again, and everything is done mod n, whatever your value of n is. Okay, so let's look at a couple of these. So if n is equal to 7 and A is equal to 1, then I start raising A to powers, and the only thing that I get is 1. That's it. I'm done. I stop. So the cyclic group generated by A is 1 in this case. It's a group. It's a set. It's just going to contain the element 1. Okay, the next one's more interesting. If n is equal to 7 and A is equal to 2, then I start raising A to powers. So we've got 2 to the first of all. 2 squared is 4. And then 2 cubed is 8, but there's overflow there because I'm working mod 7. So 8 mod 7 gives me 1, and then I'm done. I stop. Okay? Everybody good? Making sense? Everybody happy? Okay, cool. All right, here's what I want you to do, and I'm going to divide you into breakout rooms because you absolutely positively need to talk to each other, because otherwise I'm going to be talking at the screen for a while, and that's not fun. So do A equals 3, 4, 5, and 6. Okay, do A equals 3, 4, 5, and 6. I'm going to divide you into breakout rooms. You can compare answers in there, and then we'll all come back together. And I'm just going to do this randomly with breakout rooms here. So you're going to need to figure out how to accept your invitation into a breakout room. We're going to do 4 people per room in here. Okay, so all rooms should be open. You should have an invitation somewhere on your screen to join a breakout room, and you should start disappearing from my screen pretty soon, hopefully. So you should have an invite. Somebody's gone. That's good. Invite to go ahead and join into a breakout room. Look where that is on your screen. Good. People are going. Good. Okay, so be talking to each other if you would, please. We want to do cyclic group generated by 3, by 4, by 5, and by 6. So take a minute. We're working with n equals 7. Talk to each other if you would, please, and then I'll bring you back together. Hi. Oh, we have one with all females. That was random. Okay, so be talking to each other, please. The group generated by 3, by 4, by 5, and by 6. And remember that we are working mod 7. So take a minute. You might want a calculator. And then I'll bring you all back together. But everybody clear on what we're doing? Good? Okay. All right. Let's see. Okay, so everybody talking to each other, groups generated by 3, by 4, by 5, and by 6. You have calculators. You're going to need a calculator for this. No, yes, maybe. Do we have any of these so far?
We need the numbers again.
So n is equal to 7. So what we're doing is working mod 7. We're working mod 7. And then we are doing A equals 3, 4, 5, and 6. So let me pop it up here. So A equals 3, 4, 5, and 6, and you're working with n mod 7. So A equals 3 equals 4 equals 5 equals 6. So be good?
3, 4, 5, and 6. Okay.
3, 4, 5, and 6. Okay, so go ahead and talk to each other, please. Okay, how are we doing? Do we have anything generated by anything?
I've got 3 and 4.
Okay, did you talk to the other people in your breakout room to check if those are right?
Not yet. I was just going to do them all.
Good. Double check and see what you get.
John, what did you get for 3?
27, 81, 243, and then 1.
Except we're working mod.
Oh, so all of them get mod 7?
Yes.
Okay.
Okay, and I accidentally closed your breakout rooms. I'm sorry. This is where I'm learning Zoom, and I did it wrong. My bad. So I'm going to put you back into breakout rooms unless you think you're done. Are you done? Back into breakout rooms. You done? You good? You happy? Okay. Sorry, I inadvertently closed my breakout rooms sooner than I was supposed to. My bad. Sorry about that. I can't exit that screen. Again, this is a learning experience for me and for everybody else. Sorry about that. Okay. Let's share my screen here. Hopefully you ended up getting values for n equals 7 and a equals 3. Hopefully those are the ones that you ended up getting. For n equals 7 and a equals 4. All right. For n equals 7 and a equals 5, and for n equals 7, a equals 6. I can want to see all of you. So everybody good on those? And again, this is posted, so you don't have to frantically copy all of it down in the PowerPoint. All good? Everybody good on those? Basic idea, process? Cool, okay, all right. We need to also then talk about something called a primitive root. So here's the next concept that we want to talk about, primitive roots. So here's your definition. P is going to be a prime number, and G is going to be an element of ZP star. So that just means because prime number, then G is less than or equal to P, and relatively prime to P, but everything is relatively prime to P because P is a prime. Here's my definition. G is a primitive root mod P if the group generated by G is all of ZP star. That's your definition. G is a primitive root mod P. So we can't ever just talk about primitive roots. We always have to talk about primitive root mod P. G is a primitive root mod P if the cyclic group generated by G is ZP star. That's your primitive root definition. So let's go back to the previous slide. What are, or how many, primitive roots are there mod 7? Looking at that list, I want fingers because this isn't quite as easy to have answers given. How many primitive roots mod 7 are there? Once you hold up fingers, then we'll do what the actual ones are. But how many? How many primitive roots mod 7 are there? Fingers are good. How many? Looking at that list.
What time are we going?
2, I'm seeing 2 primitive roots mod 7. So my primitive roots mod 7 are going to be 3, right? Because I get the whole group, and are going to be 5 because I get the whole group here. Okay, so 3 and 5 are primitive roots mod 7. Everybody good? 3 and 5 are primitive roots mod 7? Okay, all right, in general, you don't really need to know this, but it's an interesting number theory thing. For a general prime number P, there are phi of P minus 1 primitive roots mod p. So that's for a general number. For a general prime, there are phi of p minus 1 roots mod p. Okay, we're going to skip over the next couple of functions, or the next couple of slides. I'm going to describe the Elgamal cryptosystem to you, and then we're going to come back and talk about why it's secure. I'm going to stop sharing my screen for just a minute because I want to pause the recording and start a new one.